So this is how to solve problems that involve changes in temperature, things cooling down, by the method of mixtures. The premise is that you have two objects or substances at different temperatures that you put together, and then they become a common temperature. So for example, you might have a coffee mug with hot coffee, and you put a cold spoon in it to stir. The temperature changes for both. The heat, the thermal energy from the coffee, pours into the spoon, increasing its temperature, while the temperature of the coffee comes down. So how do we solve problems that involve this kind of situation? Well, you need to remember the following. The heat that is lost by the hot object, assuming conservation, becomes heat energy gained by the cold object. And that's an equation that we can use. So if you look at the following example, a 2 kilogram lump of cast iron at 90 degrees is put into a plastic bucket containing 10 kilograms of water at 20 degrees. What is the final temperature of the water and the iron together? So first, let's think about the heat energy lost by the hot object. The hot object is the 2 kilograms lump of cast iron. If we remember, the formula for heat energy is Q equals mc delta T. So what energy was lost by this cast iron lump? It's equal to 2 kilograms times the specific heat capacity of iron, 500, times its change in temperature. Now it's gone from 90 and we don't know, okay, because as it states here, we need to find the final temperature. But we know that it started at 90, okay, and it became, we'll call it temperature X. Now where did all of this energy go? Well, the water was at 20 degrees. So all of this energy went into the water. So let's have a look now. Q of the water, and let's call that Q of the iron. Heat, thermal energy in the iron, thermal energy in the water. This time we've got a mass of 10 kilograms times specific heat capacity of water, 4,200, times the change in temperature. Now the change in temperature ends up at X, but it started at 20, so the change would be like this. So if now we have a look at this equation, again, heat energy lost by the hot object, by the cast iron, becomes heat energy gained by the cold object. So we can put these two equations together. 2 times 500 is 1,000, so 1,000 90 minus X equals, this becomes 42,000, 42,000 X minus 20. The rest is just algebra. Expanding out the brackets gives us this, and then tidying it all up, which then gives you this, and then simplifying again, we should get a value for X of 21.6 degrees. Okay, work through it yourself slowly to make sure you get the same answer.